just 40 light-years away, in the constellation Aquarius, lies a planetary system so extraordinary, so rich with promise, that it has forever changed the way we look at our place in the universe. This is the TRAPPIST-1 system, a miniature planetary family orbiting a dim, cool red dwarf star. But what makes TRAPPIST-1 truly astonishing is not just its distance or its star. It's the fact that all 7 of its known exoplanets are approximately the size of Earth.7 Earth-sized worlds, orbiting a single star, many of them within the so-called habitable zone, the sweet spot around a star where temperatures could allow liquid water to exist. This system is not only unique in its architecture, but it may also be our best shot at discovering extraterrestrial life beyond our solar system. A new era in exoplanet exploration. Since its discovery in 2017, TRAPPIST-1 has become one of the most intensely studied planetary systems in the cosmos. NASA and ESA have trained the eyes of their most powerful instruments on it, from the Hubble Space Telescope to Spitzer, Kepler, and now the James Webb Space Telescope JWST, a technological marvel that has opened a new window into the atmospheres, compositions, and even potential biosignatures of these distant worlds. Each planet in the TRAPPIST-1 system is tightly packed, orbiting much closer to their cool red dwarf star than Mercury orbits the Sun. Yet, because their star is far dimmer and cooler than our Sun, these worlds may still be temperate, with some residing in the habitable zone. JWST has already begun peeling back the layers of mystery surrounding these planets, with spectral data that hint at atmospheric gases, volcanic activity, and even the possibility of water. Let's take a journey through each of these worlds, each a unique puzzle piece in the grand search for Earth 2.0. TRAPPIST-1b, the volcanic frontier. Closest to the red dwarf lies TRAPPIST-1b, a world scorched by the heat of its host star. For years, it was thought to be barren, airless, dry, and lifeless. But now, James Webb's Mirror instrument MIRI has captured hints of a thin atmosphere. A possible veil of gases, perhaps generated by volcanism or surface chemical reactions. Thermal emissions detected by JWST suggest a dynamic world, possibly with a solid rocky surface and ongoing geological activity. Could it be venting gases from its molten core? Is its atmosphere made of water vapor, carbon dioxide, or something even more exotic? For now, scientists believe that TRAPPIST-1b is inhospitable to life as we know it, but it remains a fascinating case study in exoplanetary geology. TRAPPIST-1c, the infernal twin of Venus ***. Slightly farther out lies TRAPPIST-1c, a world once believed to be cloaked in a thick, suffocating atmosphere like that of Venus. Older measurements suggested crushing pressures and blistering heat. However, JWST tells a different story. Recent spectral analysis hints at a thin shell of CO2 rather than a dense atmospheric soup. This paradox, conflicting data from 2 different space telescopes, has left scientists puzzled and intrigued. If TRAPPIST-1c is even a tenuous atmosphere, there could be climate processes at play, winds, storms, and perhaps a geologically active surface. While life seems unlikely here, the planet challenges our understanding of atmospheric evolution. TRAPPIST-1d, a candidate for life. Now we enter the habitable zone, a region of space where the temperature is just right for liquid water. TRAPPIST-1d orbits here, basking in just the right amount of starlight to raise eyebrows and elevate hopes. This planet has not yet been studied in detail by JWST, but early indicators suggest that it could harbor a moderate climate. If an atmosphere exists, and that's a big if, it could be retaining heat and possibly supporting liquid water. Once JWST focuses its sensors on TRAPPIST-1d, we might detect water vapor, oxygen, methane, or other potential biosignature gases. Could this be the first truly Earth-like world beyond our solar system? TRAPPIST-1e, the crown jewel ***. Among all the planets in this system, TRAPPIST-1e stands out as the most Earth-like. JWST has already provided clear measurements of its density, size, and orbital parameters, confirming that it is a rocky world, much like Earth. But the real revelation came from spectral analysis. JWST detected signs that TRAPPIST-1e may have a thin atmosphere and potentially liquid water. Even more tantalizing, there are hints of oxygen and methane, gases that, in specific ratios, are hard to explain without invoking biological processes. This doesn't confirm life, but it nudges open the door. TRAPPIST-1e is now one of the top contenders in the search for extraterrestrial biology. TRAPPIST-1f, a subsurface ocean, ****. As we move outward, we find TRAPPIST-1f, a cooler planet that receives just a bit more light than Mars. It's likely too cold for surface water, but there may be liquid water underground. How can we tell? Through light reflection patterns, the way sunlight bounces off the surface and interacts with potential subsurface layers. JWST picked up signals that could indicate hidden lakes or aquifers. If TRAPPIST-1f has a dense atmosphere, it could trap heat and support a liquid water cycle beneath its frozen crust, a scenario strikingly similar to Europa or Enceladus, the icy moons of our solar system. TRAPPIST-1g, the icy giant ****. Farther still lies TRAPPIST-1g, likely an ice-covered world with a very thin atmosphere, if any. It receives little light from its red dwarf host, suggesting that its surface is too cold for liquid water. But beneath that icy shell, possibilities abound. Tidal forces from the star and gravitational interactions with neighboring planets might provide internal heating, enough to maintain underground oceans. These conditions mirror those found on the icy moons of Saturn and Jupiter, where life might exist today. TRAPPIST-1h, the final frontier. The outermost known planet, TRAPPIST-1h, drifts in the system's frigid frontier. It is likely a frozen airless world, beyond the range of liquid water. Yet, even here, all may not be lost. If it is geologically active, if it has a warm core or experiences tidal heating, there could be liquid reservoirs below its icy crust. JWST is still collecting data. We don't yet know whether TRAPPIST-1h is truly a dead rock or a world with secrets beneath the ice. A universe of possibilities. The TRAPPIST-1 system has become more than a curiosity. It's a laboratory for understanding planetary formation, evolution, and the ingredients of life. It offers a breathtaking range of environments, from scorching volcanic lands to frozen ice worlds, and perhaps temperate oases where life might exist. What if multiple planets in this one system are habitable? What if, just 40 light-years from Earth, there exists a family of worlds teeming with microbes, forests, or even intelligent life? These aren't fantasies anymore, they're scientific questions, and we finally have the tools to answer them. As the James Webb Space Telescope continues its mission, each new data point adds another brushstroke to the cosmic canvas. TRAPPIST-1 might not just be a place we study, it might be a place we visit one day. Subscribe now. The next chapter in humanity's journey into the stars is just beginning.